Welcome back everyone, and today we're back with more WebGL, and today we're going to cover picking and frame buffers. The idea of picking is to be able to select a 3D object in your scene and then actually move it around. We're gonna do this by using frame buffers. Another solution for picking objects is through raycasting, but raycasting requires us to set up collisions and in volume collisions and learning how to intercept or find the intercepts between the ray line and all these volumes. So since that's more of a complicated, and that's something we should probably deal with later on, when we want to deal with collisions, the frame buffer is the simple solution where we kind of use color as an identifier in the scene. It'll make more sense once we get through it. So one of the first things we're going to do is start doing some changes to our fungi core to accomplish some of the features that we want to do with frame buffers. So one of the things, and there's some bug fixes too. Inside our transform class, I got rid of or commented out the Quintorian versions of left, up, forward. In the previous lesson, when I refactored it, it seems to be working, but it doesn't. When an object is in motion, it doesn't work. It does not give me the proper forward direction. I think the only reason why it looked like it was working correctly because a Quintorian with doing no actual rotations creates like a value of 1, and then using these set values of 1. So it looked like it was working, but it's not. Reading into more about Quintorians, you can't really rotate a vector with a Quintorian. You kind of have to convert it into a matrix and then use that as a multiplier on this. So there's really no point in me actually converting this into a matrix, a rotation matrix, and then multiplying it, since an actual transformation matrix actually has the values in there. So I went back to the original code that I had from a lot of previous lessons where we use our model matrix to actually pull out the right, the top, and the forward directions. But I did a couple of new additions to it. Originally I had D for distance, so this way I can add a multiplier to our directions, because most often if you're looking for a direction, you want to multiply it by some kind of scalar value. So I thought it'd be just easier and to just have that functionality into our directional functions. So this way we're not calling two functions and doing two multiplications. We can do it all in one go. What I added to it is V for vector. So this way we can pass in a vector that we can update. If we're doing a lot of vector changes, it makes more sense to use a single variable and just update the variable, kind of like through reference or through like a pointer type of thing. So we have a vector, we pass in the vector, and if the vector is undefined, we create a vec3. But by default, it's not always going to be a vec3. It can be just any array. I built it this way kind of because, I wanted to, the example that we're doing today, I'm going to use a regular JavaScript array because that's faster and I guess uses up less memory than like a float 32 array. So that's why I kind of did it. And there's this one little bug. Apparently using that kind of OR statement doesn't work very well with numbers. It works fine with objects. But if you're dealing with numbers and undefined, it seems to act a little buggy. So I changed it to if D equals undefined, set it to 1. So I can actually get rid of this because we don't need this anymore. So, and we can get rid of this because this just doesn't work with Quintorians. I just left it in here for you guys to see. And this would basically be the only change I did to, yep, I think it's the only change I did to our transform object. So in Renderable, I added a new function called draw. I just added it as a shortcut because since we're doing multiple draws to do frame buffers, I make it a little easier to do a second call without actually duplicating this. So this through 2 lines of code actually exists twice. It exists here in Renderable, and it exists in our render function. I don't want to call this because I don't want to call another function in the render function. I just want to keep. I want to go as fast as possible. So one last function call, the better. So it's duplicated, but it's not that big a deal, as long as I don't go too crazy with it. What other changes we need to do? I don't think we did anything in here. All our Vec3 objects are fine. Matrix and Torians, all of that is good. I feel like I did something in Shader Builder, but I don't think I did. I think Shader Builder is fine as well. Yep. I did probably small changes like dispose still had this.gl, and apparently some of them still do, but I'm not really using any of these functions. I'm still finding these, but I'm not using them, so that's why I haven't seen the errors yet. But I think dispose and pre-render, I'm getting rid of a lot of this.gl from the pre-factored code. So these are just small little things. This is going to be the big meat and potatoes of the lesson today, but we'll save that for last. I just want to do a couple more changes, show you some changes. In our resources, we're adding an FBO cache variable, so we can just store all our FBOs there. And I added to shaders the FBO class, so this way we can access it outside the core file. So now if we go and also did some changes to render. Originally, the render function, I would return the function directly here. Now I actually save it to an F variable, so this way I can add a callback function into it. What I want to do is that when I'm done rendering an object, I want to then call an event if it has been assigned, like a callback on item rendered. The idea is that when we're drawing frame buffers, we're going to draw to the main frame buffer, the display buffer that actually draws to the canvas, and then we're going to draw to our custom frame buffer. So we have to draw twice. So since all of this sets up the shaders and everything else for drawing, instead of redoing all this all over again, it's like, well, I'm done drawing to the display buffer. Here's a callback that allows me an additional thing I can do, which in this lesson, we're going to just draw into our custom buffer, a frame buffer. So that's the reason why this is there. So we can have a little bit more control of our render without creating a new render class or a new render function to handle things. So that's our render. Now we're going to the meat and potatoes. Now it's a frame buffer. A frame buffer is what we've been drawing to this whole time. It's basically just a giant array of numeric values. That's all it is. It's exactly what our vertex buffer is. We restore all our vector points. So there's really like no difference. Everything is an array. You should kind of realize everything in WebGL and OpenGL in general is just a bunch of arrays, a bunch of numbers. So there's something called the display buffer, which is where we actually draw to the canvas. And the frame buffer is composed of actually 2 buffers inside of it. There's a color buffer and a depth buffer. The color buffer is where we actually draw all our pixels. That's where the fragment shader actually draws everything into. When we send the color out at the end of our fragment shader, that pixel color goes and gets stored into the color buffer of the display frame buffer. Now we also have a depth buffer, and a depth buffer just stores the Z position of that pixel. So by default we have depth testing turned on. That means anything that's close to the camera gets drawn on top of anything that's further away from the camera. So if we turn off depth testing, that means everything will be drawn in the order that's drawn. So if we draw something close to the camera first, and then we draw something far away from the camera, that far away thing will get drawn on top of the close thing. And that's not good. So that's why we have depth testing turned on. So this way, anything further away does not get drawn. Or gets drawn, but then gets overwritten by things that are closer. So that's what a frame buffer consists of, a color and a depth buffer, which allows us to do the depth testing. So if we were creating our own frame buffer, the bare minimum we need is a color buffer inside of it. And from there, you can actually add as many color buffers as you want. I think there's actually a limit. I think it's 10 or 14. I forgot. But you can add quite a bit of frame buffers, but it's not a tremendous amount. Then you can add one depth buffer to your frame. And there's something else called stencil buffer, which I have not got a chance to use yet, and I haven't read too much into it. So that's a different type of buffer you can apply to your frame buffer. And I know you can somehow, I don't know if it's in WebGL or just OpenGL, that you can combine a depth buffer and the stencil buffer together as one buffer. So this way you don't have two things. You can actually use them both together. But I'm not sure if that's a WebGL thing or it's just an OpenGL thing you can do. So the bare minimum to create a frame buffer is a color buffer. And you can create a color buffer two different ways. You can do it as a texture, or you can do it as a render buffer. A texture allows us more functionality. We can actually reuse that texture buffer and use that to draw onto a quad or a cube or whatever. And you know, there's some cool things you can do. I'll probably explain later on. So let me just say what it takes to create a frame buffer. A frame buffer, here we have I have all the steps as their own functions. We just create the frame buffer space on the GPU, just like we do with any other buffer. Then we bind the buffer to the global variable that kind of holds the currently active buffer. So, and mind you, when we're binding, this is our custom buffer. If we ever want to go back to the display buffer that goes into the canvas, you just do bind frame buffer null. That means null is the default display buffer. So right now we're going to make our custom buffer the active one. So this way, when we start doing things, we it gets applied to that buffer, that frame buffer specifically. So that's how we create a frame buffer. Just that line, and we bind. So like I said, by default, we need at least one color buffer. And I created this function called TextColorBuffer, which creates a color buffer from a texture. And it's just like the textures that we've done in the past. So, we create the texture, we save its ID, we bind it as a 2D texture, and here we create the actual space on the GPU. And the only thing that you might not notice is that we need to supply a width and height for the texture. And the width and height is the size of our canvas. Because you got to remember, we are basically redrawing the canvas. This our custom frame buffer to allow us to do picking is we're going to redraw the entire scene again twice. So we need our custom frame buffer to be just as big as our display buffer. And then we just tell it what kind of data we're storing. We're going to store RGBA, which is the standard color buffer information that we store in our display. So it's basically we're recreating our display buffer all over again. And we're just setting up traditional, regular, simple things. And then once we have our texture buffer, or our texture all set up, then we apply it to our frame buffer and we attach it. And I pass in cAttach number, and let's see. Let me go to here. Here's a function that's going to build our standard custom buffer. So basically, we create a buffer, and here we create our text buffer, and we pass in color attachment 0. And remember, I said we can add several color buffers to our frame buffer. So right now we're going to define 0. So when we create our texture, we bind it to the color attachment 0 of our frame buffer. And that's what we're doing. We're just attaching it. Since we're going to use it for rendering, basically we need depth testing for our custom buffer. So after we're done setting up our texture, the next step is to really create a depth buffer. And our depth buffer we just use a function called create RenderBuffer, which is just a different type of buffer we can use. I don't know the difference between it, but I think it's just a regular simple buffer of array information. And again, we bind it globally, and then we set it up to have a component 16. And this is basically, I guess, kind of creates each chunk of data inside our buffer, or I guess each pixel in our buffer is going to be 16 bytes, which basically is our float, or like 4 floats. So this way, I guess we can store our RGB, or actually, well, the depth buffer actually doesn't store color. It stores kind of like the position. So it stores X, Y, Z, and W. So that's why we have 16 instead of like 12. And of course, our depth buffer has to be the same size as our canvas. So that's why we're just applying the canvas size. And then after we're done setting up our render buffer, again, we just bind it to our frame buffer. And instead of using the color attachment, we use depth attachment. It's kind of like our VAOs, where we can add a bunch of buffers to it, but we can only apply one index buffer to it. So I think, same thing with frame buffer, we can only apply one depth buffer to it. And I think we probably can only attach one stencil buffer as well. Color buffers is that we can actually add multiples of. And when you're all done with that, then we do the final step where we finalize our frame buffer. And all we do is have a function called check frame buffer status. And then we get back a bunch of codes. As long as you have a color buffer set up, and you're good. You might get different errors, like let's say the color buffer and the depth buffer don't match, like they're different sizes. Or maybe you apply 2 color buffers and they're both not the same size, or there's a bunch. Here's all the errors that can probably happen when you create your buffer. So we'll just check to see if the buffer is perfectly fine, and then we unbind everything that we worked, and then we save the cache, and we're done. And that's it. And that's our frame buffer. And like I said, and we create this one function to kind of facilitate all this work in one go, because most often we're just going to create a color depth buffer, or we might create kind of some other type of buffer which we might have predefined. So this way we can just create functions here. That's something we're going to use a lot of. So this way we can do a lot of it in one line of code and just get it over with. Just standardize a couple of things. Now a couple of other things we can do. We have read pixel. Read pixel is very important for today's lesson. And what it allows us to do is read a pixel from our color buffer inside our custom frame buffer. So to read a pixel, all we do is bind our frame buffer, and then we read the pixel based on X and Y, Z, tell it what kind of information we're getting, and we pass in P, which is our uint8 value. So this way we should get back RGBA. And it's that simple. And then we just have some simple things, how to activate a frame buffer and deactivate. Like I said, this one sets it back to the display buffer. And then we have clear. And every time we render a frame, we have to apply a clear. That clear just empties out our color and display buffer inside our main buffer, or depth and color buffer. So during every single frame, we also have to clear our custom buffer. So this function facilitates that. It binds our custom, and it clears out the color and the depth, and then kind of resets it back. So, and then we have a delete, which we're not using, but we can then pass in our FBO, and it kind of just deletes the frame buffer, the render buffer, and the texture buffer. I have a to-do. Delete functions work differently, but since I'm not using it, that's why I don't have it that way. So that is our FBO. Now we're going to do one more big change, and that's going to be our camera. Before we had our camera controller, and to do what we're doing now, I need to be able to control the camera in a different way. And instead of just creating a whole new camera controller to handle picking, I decided that, you know what, it might be better just to rewrite our camera controller. And I'm creating a new class called KVM Control. And KVM Control is, I just call it for keyboard and mouse controller. And this object is built differently than this one. This one is meant to be kind of like a state machine. So basically, all this thing does is handle the data related to mouse input and keyboard input, and then you have to pass in objects that actually handle and that interprets that information to be used in a certain way. So our KB controller has our constructor, and it has all the stuff we need to handle mouse input. And so, we're going to keep track of the starting point, the previous, and we have our bind, and we keep track of our the size of our canvas. So this way we can compensate where the mouse is in relation to where the canvas is on the page. This is very similar to this. And then we have something here. We have on-down override. So this allows us to kind of customize which state handler, which state machine, or which state we're currently in to handle the mouse or the keyboard inputs. And then we have an active handler, which one is currently active, and our handler object or array or whatever you want to call it just keeps track of the list of handlers that we have set up. So this way we can actually use a switch handler function. You'll see it in the example. So we can switch back and forth between all the different handlers. And then we add add handler, which just gives it a name, the actual handler object, and is it active. So this way, if it's true, it sets that one as the currently default active one. And on set down override just sets the callback to handle the handlers. And then the rest of the object is very simple. Like the mouse wheel, it checks to see if the handler exists, then it returns if it doesn't exist. And it handles all our details and then pushes that data to the handlers on wheel event. So like I said, this object, all it does is handle the data related to mouse and keyboard input. It does not know how to use the data, it just knows how to manage it. So we have mouse wheel, we have mouse down, we save our data, we do our down override, if it exists, let's do it. And then we do our on mouse down handler, and we pass in the event. We pass in a reference back to the main state machine, I guess you want to call this, and then we pass in the current X and Y position from the mouse. And we kind of set up our mouse move event. I set up the mouse move event. I disable it and re-enable it during the down and up because I don't want to have the event set up and then every time the mouse is moving, the event is being called nonstop. It's better to have the event not there firing when you don't need it. So the only time we need to worry about when mouse move happens is when the mouse down event gets started. So that's why for mouse up, I remove the listener. So this way, when you're done moving the mouse around, it unbinds it. So this way, we don't have an event constantly firing because I don't want to add into this function to say, like, I don't want to have like a thing saying, are you currently dragging? Is dragging. If is dragging, do this, else return or exit. It's just easier and more efficient to just not make that available when you don't need it. So that's why I'm adding and removing the listener on mouse down and mouse up. And then on mouse move, like I said, we handle all our data, and then we call the event. It's kind of like rinse and repeat the functionality. Mouse up, and we didn't have this before, but now we have mouse down and mouse up. So that is our KVM controller. Now, the KVM controller viewport is now this functionality that we had. it has all our, this one actually uses the camera, so you have to call it with the camera object instead of this one. Like, so this one has no clue what it's being used for. It's just a data handler. And this one is like a data user. And it has all the information that we had previously in here. On wheel, it changes the camera Z index. On mouse move, it handles our rotation or our panning. And on keyboard down, on key down, this is new, which you might have fun, is that I added a little bit of keyboard controls to our viewport. So this way we can kind of use the WASD controls to kind of move around, and then Q and E does rotation left and right. So now you can use the keyboard to control the viewport. And that is our viewport controller, our handler for our KVM controller. Because we're going to actually have two handlers. This one's going to be standard. We're going to use a lot in the future. Basically, like I said, it's going to replace this. This is probably going to go in the garbage, and I'm going to rename the file to KVM controller. So now we go to here. Now this is going to be our test page. Now I started off here down here in the shader, because the first thing we're going to do is add this to the shader. We're going to add a blank color, which is a constant. Then we're going to check to see if we're currently drawing. Because if we're currently drawing to the display frame, we're going to pass in a uColor ID that's equal to blank color, which is going to be just a black color. If we're drawing to our custom frame buffer, we're actually going to pass in a color ID. So you got these two lines of code, and you got this new if statement, or this added to the if statement. So if color ID not equal blank, then our color is our color ID, else we color everything else. And that everything stays the same. And you might say, well, color ID. Well, the idea is, I don't know if I explained in the beginning of the video, is that we're going to draw our scene twice. And the way we're going to do it is we have our custom frame buffer, which is going to be drawn with a single color. So there'll be no shading, no lighting, no nothing. It's just a single color that's applied to that object. And each object gets its own specific color. So we can convert an ID number into a color. So we do this with this function, which I'm putting it here because I don't know where to put it in the Fungi core or Fungi functionality. So this stuff is just custom. I don't know where to apply it into the project. But for now, this is where everything's going to be stored, just handled just for this lesson. But ID color, it turns an integer into a color that value that can be read by GL, WebGL. Remember, it's going to be an array of 3 components, and it has to be a value between 0 and 1. So we're doing a bunch of bitwise operations to do that. So basically, I don't know if you need me to really explain this part of it, but I'm just kind of just shifting bits around and trying to take the number, like the base, like we're going to start off with the ID 100. So ID 100 is going to make this element equal 100. This is going to equal 0. And that's going to equal 0. And don't forget, it's going to divide by 255. So we're going to get a nice number equivalent. So if this is 100 and this is 00, the final color is going to be some shade of red, kind of like some kind of dark red color. And when we click on the mouse and get the pixel color of that point that we picked, we're going to get that red color. And then once we get that red color, we can use color to ID to compile it back into an ID number. So let's say if we have like 50 items and we start off at like ID 100 and then ended at 150, we can then pick each object on the screen and then check to see which object has that ID number based on that color. So that's what we're doing. So it's a kind of like this kind of a lot of smoke and mirror magic, basically, to get it done. But this is like the easy way of doing picking, as opposed to doing ray casting and collision detection. And here's our other controller handler. And this one, this one is that if we clicked on an object on the screen that has an ID, we're going to switch to this handler, and this allows us to move the object on the screen. So on mouse up, we're going to switch back to our camera handler. So once we're done moving the object, we're going to switch back. So this way we can then rotate and control our viewport again. And while the mouse is down and while this handler is active, is the active handler, it's going to have the mouse move event. And I don't know why. I had this for testing, even though I'm not really using it. I'm using DX and DY. So what I'm only doing is I'm just creating an array, and I'm going to take the left. I want to know, because I want to know where the camera is currently pointing. I want to move it to the left and to the right, or up and down and left. But basically it's based on the orientation of the camera. So we're not gonna randomly. We're not gonna do it just like based on the axis. We're actually gonna be based on where we're looking. So if we rotate the camera in a certain direction, we'll actually be able to move the object based on the current location and rotation of the camera. So getting the camera's left, we pass in the function or the array that we want to update. We pass in the change in the D, or the delta X position. How much did we move from the initial to the next? So it's like the increment of how much we moved times this rate, and this rate's up here. You can change the rate to see how to make things move faster and slower. So it's the delta X times rate, and we do the same thing with this. With Y. So up and down, we just do the negative because we're going in option direction. And that's our picker. So now if we scroll up to the top of our HTML page, I think I added these two new variables and all these variables. So we're gonna hold on to an FBO. This is our ID for the object that we're handling. We're going to store its color ID, which is going to be an array, and we're going to handle a blank ID, which is going to be an array. And the right to start with is we convert 100 into a color ID that we can use, and then we have ID to color, which is 0, which creates a black color for us. We have our init that doesn't change, and now our render. We're going to update our render with an on-item rendered callback. And as you can see, the item that, let's say currently, if the item is currently just picked, grid floor, we're just going to exit out. We're not going to re-render the grid floor in our custom Framebuffer. Ideally, if you have a bunch of objects, you basically check to see if the item has like an ID. If the item has like ID, or you can say color ID or picker ID or something like that, then you can do this. So, this is like a bare bones example, but if you're going to do this, you're going to have to do it right. Like I said, right now I'm just doing one item, and I'm actually not gonna search for the item on the list because on the screen, because I only have one item. But like I said, if you do have an item, you might have to update the renderer object. You come up with a different way how you want to manage it, or you just put everything into an array that has an ID. There's so many ways you can apply it to. But this is just a general idea, is basically, if an item has an ID or a picker ID or is enabled to be a picker or whatever reason, then we kind of use that for drawing. So if we have an object that we are going to use for picking, we set the uniform for our shader. We pass in the color ID that it has. We activate our FBO. We draw it. Remember, that's the new function we just added to our renderer class. We deactivate it, and then we set the uniform back to blank ID. So this way, the next object or the next frame, we're back to drawing in our display frame shader. Then we create an FBO. We're still kind of just getting things ready, and we give it the name picking. So this way we can get it back out of the cache if we need it. Here's our new camera, because this is what our camera looked like I updated it with on down override, but then after I kind of upgraded this camera to be used, I realized this is stupid, kind of not the smart way of doing it. That's why I rewrote it to kind of be kind of like a state machine type of thing. So here's our new camera. We tell it, here's our controller. We add our handler. We're calling it camera. It's going to use our viewport, which is applied to our camera. We add another handler. We're calling it pick. And it uses our custom handler that we have on this page. And then we set our down override. And so when we press mouse down, the first thing it's going to call this function first before it handles anything else. And we have the X and Y position. The first thing we got to do is that we need to convert, we have to invert it. That's why I have YI. Because the coordinate system, when dealing, I guess, with the textures, it doesn't start at the top left. It actually starts at the bottom left. So down here is where 0, 0 starts. But on the web page, a web page, 0, 0 origin is at the top left corner. So we got to take height minus by Y, which kind of inverts it into the origin starting at the bottom left corner. So we invert the Y, and then we use the X works perfectly fine, and then inverted Y, and we read that pixel in our frame buffer. And then we take our pixel, and then we call it color to ID, so we have our ID. And if the ID equals 0, which is black, or if the ID equals this number, it equals white. This is the maximum ID number we can use using RGB. Sorry, we can't use the alpha. We can't use alpha because if we're using blending, then the color will change. So if we draw something that's far away from the camera that might be blue, and then we draw something close to the camera and it's red, and if we use the alpha, when we're drawing, we might accidentally blend the colors together, so it wouldn't be blue or red, it'd be a mixture based on the alpha blending. So that's why I'm not using alpha for this. I'm just sticking with RGB and not RGBA. So without using the fourth float, I can't get up to the 2 million or 2 billion number, or 2 billion actually, or something like that. I don't know. But using 3 floats, this is the maximum number we can use for IDs, which is a lot. That's a lot of objects. So basically, when I click on the mouse down, if it's not black, if it's not white, then let's switch our handler to the pick handler. Remember here we're setting up the handler, and then it uses that thing down here that we have. So once the mouse down event is done, it starts using this object's on mouse move event. And that's it. And that handles our camera controller. And I can get rid of that because we don't need that anymore. I just wanted you guys to see that. So for our shader, we have this uniform that's standard. It's our model, uni, matte, whatever. And then here's our color ID. We're setting a vectory. So this is 2 uniforms. It's just an array. That's the only change to that. I probably just create a G model, commented out debug lines. We're not using debugs for this lesson. Here's our floor, and here's our render list, and we just put those 2 together, and our loop. And then our render event is the same. Nothing has changed. Well, this changed. For every loop, we clear out our custom FBO. Sorry. And that should be all the changes we have. So if I go to the browser, just refresh it. Oh, I broke something. What the hell? Damn it. That's what I get for clicking save. Oh no. Did I screw something up? Damn it. I must have took something out that I shouldn't have. Just undo everything. Refresh. Ah, see? Quick and easy fix. I must have deleted something I shouldn't have. So, so as you can see, we can still rotate. We can control our canvas. The moment I click on the box, I move the box. I click out, I can move it. I can use our panning, and like I said, it's based on our view. So now that I'm above, I can just move it around this way. So and there you go. That's the picking in general. Now I'm going to show you what's actually in our Framebuffer. So an easy way to see what's in our Framebuffer is, why not just never set the color back to blank. So if I refresh, there you go. This is what, minus the grid, this is what's in our Framebuffer. And our Framebuffer is basically a white background and that square. And that's colored that one color. So if I can pick any little spot, it knows because it's that color. So if I pick here, it'll end up picking white. If I click here, it'll be white, 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 white. But when I click in that area, it knows is that red color, and it gets back that ID number 0 based on the RGBA being converted back to an ID. And this is what, like I said, the Framebuffer that we're creating is drawing. It's just drawing this, and our display buffer is drawing the actual square that and this is what our display buffer is. It's the square that we actually colored. You know, one red with the green side and the gray. And that is our custom Framebuffer, and this is picking. Now, if you want to put a bunch of objects in here, each one can have its own specific ID number that has an actual color applied to it. And then when you click on it, you know, you just change, I guess, the down handler to find which object you're picking, and then maybe set some global object to, or global variable to say, okay, this is the currently selected object, and then you have the handler, the pick handler, actually moving that specific model instead of being hard coded to use that one, only the single model, or that single model can be the global variable. And like I said, that's all it really is to it, and it works really well. So it's once I got rid of the Quaternions for picking direction, it works beautifully. Let's see if I can zoom out. It's hard to zoom. My mouse has a horrible scroll wheel. So this is fun. This is great. I love this. This is great. We're finally able to interact with our 3D space. And you can see that the mouse doesn't line up with the object. It's because I'm zooming out. The Z distance between the camera and the object should probably be checked, and then based on some kind of ratio is how much the rate should be. So like for this, the rate should be smaller based on the Z distance between here and here. Or you can do a distance check, like current camera position, current position of this object, and based on maybe some kind of ratio creates the rate in which we allow the direction to move per frame. So, but like I said, when we get closer to it, it renders better. You know, like it's 1-to-1. But that's because I played around with it with trial and error to pick a rate that works really well. So to really make it smooth, you might have to work a little bit more to get it working just better, like when you're zoomed in, zoomed out, and just kind of create a nice ratio. I'm not sure how to go about it, but that's the idea, really. And that's really it for this lesson. So right now we got frame buffers, and then now the only problem is that we're drawing to two buffers at the same, two different buffers, and we're rendering twice. Now WebGL 2 allows us something called multi-render targets. This allows us to render to two buffers in one go. So in the next lesson, we're going to redo picking, but we're going to use MTR, multiple render targets, MRT. We're going to use the MRT functionality. It's an acronym. So this way, the idea is that we set up we still have to set up a custom buffer, but our custom buffer will have 2 color buffers in it. So our frame buffer will have, let's say, a color buffer with attachment 0 and a color buffer for attachment 1. 0 will be this that we see, everything we see here, the grid and the box the way it is. And the second one will actually have the color ID of a specific object. So when we draw, so ideally, when we draw the grid, if the grid doesn't have an ID number, it doesn't get drawn at all. So we'll just have to we have to code our shader to handle that. So this way, when we call the shader, we can do this frame and 2 buffers at the same time. And then the idea is then we can then take the 2 frames and then kind of render it to the canvas after. It becomes a 2-pass process. I don't want to go too much detail. I'd better save it off to the next video. But let's just say the next video we can do some fun stuff, because we can do post-process effects, and we save time on doing 2 frame buffer 2 buffer renderings in one go instead of doing it back and forth, because right now we're going back and forth between the display buffer and the custom buffer for every frame for every object. So multi-targeted rendering will actually make things a lot smoother, and like an overall gives us a lot more functionality. We can do some fun stuff that I've been reading about. So that'll be it. Looks like this video probably was about almost an hour. It is 1 in the morning, and that's it. That's frame buffers. That's picking. Now you can interact a lot more with your 3D environment. Catch you guys later in the next lesson.